Ocean worlds around our giant planets are there to be discovered. Europa Clipper is being built to do just that. Let's find out what it can do.
Hi, I'm Jim Green, Chief Scientist at NASA, and this is Gravity Assist. On this season of Gravity Assist, we're looking for life beyond Earth.
I'm here with Dr. Bob Pappalardo, and he is a senior scientist at JPL in the Planetary Science Division. He's also the project scientist for the NASA Europa Clipper mission that's going to Jupiter's moon, Europa, a beautiful ocean world. Welcome, Bob, to Gravity Assist.
Thank you, Jim. It's so good to see you, and I'm so excited to be here.
Well, how did Jupiter get so many moons, and why are they so different?
Well, Jupiter has something like 79 moons. Most of them are little shards from collisions, or Jupiter captures objects that are passing by. But it's these four big ones, the Galilean moons, that are the ones that are much more like worlds. Ganymede is larger than the planet Mercury. And those four were created along with Jupiter from the same cloud of gas and dust. And the inner one, Io, lost most of its water. Does not have an icy surface. The outer two, Ganymede and Callisto, have lots of rock and lots of ice. And Europa is kind of in between, with a bunch of rock and then a skin of H2O, some of which is solid ice at the surface where it's so cold, and some of which is liquid water, we think, down below the surface, which makes Europa so fascinating that there's a liquid water ocean in there today. It's pretty close to the surface, 13 miles or so, and probably it's in contact with rock below. So nutrients can seep into that ocean and potentially serve as a fuel for life.
Well, you know, in our ocean, at these hydrothermal vents, we see life all over the place, and it doesn't require light from the sun. Is that a similar process that may be going on at Europa, or do we need sunlight to have life?
We're not talking about fish and whales. That would be exciting, giant squid or something. But instead, probably just single cell organisms down there. Beneath Europa's icy shell, light is not going to penetrate. So it's not life that's dependent on photosynthesis that we're talking about. Instead, life that's dependent on chemical reactions, similar to some life on Earth.
Well, over the last several years, another set of fantastic research has been done concerning the possibility of seeing geysers coming out from cracks. When we look at Europa, we see these crack structures everywhere, and yet maybe some of them are active. So what do you think about the possibility that life gets scooped up and ends up in these plumes?
Yeah, there's tantalizing evidence of these plumes from the Hubble Space Telescope and other observations that says maybe every once in a while Europa lets out a big burp of activity. When we're there with the Europa Clipper, we might be able to fly through such plumes. If they're there, we need to confirm them. There might be a range of sizes. We don't know, are they consistently active or sporadic? What sets them off? And can we fly through them to directly sample the interior of Europa?
So Bob, when is it going to be launched? When will Europa Clipper be on its way?
We're scheduled to launch sometime in the mid-2020s. And then depending on the launch vehicle we take, it'll take a few years or up to maybe 6 years to get out to Jupiter. And we might go on a direct path, or we might need a gravity assist.